Hello and good day geometry. We are going over CO31, which is an extension to what we talked about yesterday with the triangle inequality theorem. Okay. I start this, Max. I'm teaching now. I start this by saying I have a triangle. I used to play a triangle game with students before, and so let's just play it quick because I feel like I have a triangle that goes from Vince to. You have?
Yeah, we played that.
Let's play one. Let's just from Vince to Alex to Kylie. Who's in the middle?
Me. Cute triangles.
You need to raise your hand, otherwise people shouting at me. I can't interrupt.
Wait a minute.
Okay.
Who to Vince?
Kylie. It was Vince, Alex, Kylie.
It's Catherine.
No. Anthony.
Where's Alex? Dennis.
Dennis.
Who?
His name.
Dennis.
Yeah.
It was Jack. Job well done. I have a triangle that goes from Rowan to Aiden to Arlene.
No.
Who's in the middle?
You have to proof it.
Not too.
It would be Mr. O'Lane.
Damien.
No one.
False.
No, that is true.
Catherine.
Damien.
Arlene
Not in the
Shoe.
middle. Damien, sit flat though, please, for your own health and safety.
Wait,
Alex.
Alexis.
No.
Quite short.
Sit flat.
What's the triangle?
Damien.
Damien's not in the middle.
He moved the shape.
Aiden.
No, not Aiden.
Arlene Shoe.
No.
Will. Arlene.
No.
Can we prove it?
I mean, put your foot back. Mr.
No.
You.
No.
Mr. O'Lane.
Anthony.
No.
Aiden.
No. Catherine was in the middle. Catherine was in the middle.
How?
Okay.
Girl eye.
You have to proof it.
So anyway, we're thinking of a triangle.
Excuse me.
3, 2, 1, 5. Damien. Noah. Face front, please. Joey said flat, please. Vince. Kylie. Turn around, please. Alex. Okay. The size of 13, 19, and n. Okay. And we don't know what n is, but because of the triangle inequality theorem, there's only a certain number of values n can be. Okay? So the triangle inequality theorem not only helps us determine if a triangle can be a triangle, if you know what all three sides are, right? But it also can help us determine, give a possible range for that third side. So knowing that in the triangle inequality theorem, it says that a plus b is greater than c, right? The sum of two sides must be greater than the third. What are three inequalities we can write using these side values here that we know have to be true? Give me one, Kylie.
13 plus 19 is greater than n.
Okay, we know that 13 plus 19 has to be greater than n, right? Because the sum of two sides must be greater than that third side. Anthony, please take out a piece of paper and take notes along the way. If you don't have a sheet, there's some paper on the Kindle table in the back there. What other inequality we know must be true?
N is smaller than 13 plus 9.
Okay, that pretty much says the same thing
Yeah,
here,
but like I said it
just
differently.
reversed.
Yeah.
Okay, Jack?
19 plus n has to be greater than 13.
We know that 19 plus n has to be greater than 13. Okay, and we know that, Catherine?
13 plus n.
We know that 13 plus n it has to be greater than 19, right? Given any three sides, we know that the sum of two of them has to be greater than the third.
Yes.
All right? Now, let's go ahead and let's solve each of these here. Well, first of all, before we even do that, which one of these inequalities is completely useless for us? Aiden?
13 plus n is greater than 19.
Nope.
19
Damien?
All of them.
Nope. Christopher?
19 plus n is greater than 13.
Why is that one useless? Christopher?
Because 19 is already greater than 13.
Yeah, we know that if we're talking about a side length, and a length can't be negative, right? Because 19 is already greater than 13, this one isn't really helpful, because n could really be anything. Okay? So we are going to, it can't be negative because a distance, a triangle side length, can't be a negative value, right? So we're going to eliminate that one, okay? And again, I'll repeat why it's useless. It's useless because 19 is already greater than 13. This gives us no information about what n could be. The other two, though, are helpful. This one we can write as 32 is greater than n. 19 plus 13. And the other one, we can do a little bit of inequality solving here, subtract 13 from both sides, and we know that n has to be greater than 6. Now, we get to go back to our days of compound inequality for and or statements, okay? If 32 is greater than n, and n is greater than 6, first of all, what's another way to write this inequality here?
N is less than 32.
Right, if 32 is greater than n has to be less than 32.
Why do we have to write it that way?
Because
Why?
if n has to be greater than 6, n less than 32,
It's a very
we know that n has to be between 6 and 32, don't we? Okay? Using the triangle inequality theorem, I'll walk us through this process again. Using the triangle inequality theorem, we came up with these three inequalities based on the fact that the sum of two sides must be greater than the third. Okay? We eliminated one of them because what was on the left side is already greater than what's on the right side. This doesn't give us any information about n. So we crossed that one out. The other two, we simplified, or we solved. We got 32 is greater than n, which can be rewritten as n is less than 32. So that gives us some information about n, right? Can't be 35, can't be 40. It's got to be less than 32. The other inequality, using opposite operations, subtracting 13 from both sides, we got n is greater than 6. So that gives us two limits that n has to be between. It has to be between 6 and 32, which we wrote as a compound inequality and statement. Jack,
The answer is 7.
how do we know that?
Because
It could be 7. What else could it be?
It's any number in between 7 and 31.
So it's really any number between 6 and 32, because lengths can be decimals, fractions, right? It could be 6.01. And so if you recall, to show this, we would put an open circle above 6 and above 32 and connect them.
Oh no, I failed this.
I think everybody.
I think I got one on this.
Okay?
I don't think I heard that.
So I said an open
I
circle.
don't.
Why is it an open circle?
Because it can't be each
Jack?
number greater than or equal.
Because it's great.
Because it has to be greater than 6. If it was a closed circle, that means it could be 6, but it can't be 6 because it has to be greater than 6.
Wait, why?
Okay. Damien?
Why can't it be 6 again?
Because the triangle inequality theorem says a plus b has to be greater than c. If it was 6, then 13 plus 6 is not greater than 19. It's equal to 19. Okay, but it could be 6.01 because that would still be greater than 19. Okay? Questions on this? Okay, let's go down to some more to practice with. We'll start the process over again. With these three side lengths here, 9, 15, and n, what three inequalities can we write using the triangle inequality theorem? Joey, give me one.
9 plus 15 is greater than n.
We know that 9 plus 15 has to be greater than n. What else do we know?
9 plus n is greater than 15.
We know that 9 plus n has to be greater than 15. And the third one?
15 plus n has to be greater than 9.
15 plus n has to be greater than 9. Okay? Just different combinations using all three the same values. Which one's worthless?
15.
The third one, right? Because 15 is already greater than 9. It gives us no information about n because n could be literally any positive value, which again, it has to be a positive value. It's a distance, and that's not going to help us. Right? So now, we can rewrite 9 plus 15 is greater than n to be 24 is greater than n. That's too much like a 7. Hold on. 24 is greater than n. Looks the same.
Oh my god.
Why can't I write greater than signs that don't look like 7s? There we go. Stop it. I tried my best. And then we can solve the second one by subtracting 9 from both sides, and we know that n is greater than 6. Okay. Now remember, that top one, that variable on the right side, 24 being greater than n, another way to write that is n is less than 24. Okay? Which means n has to be less than 24, n greater than 6. So the compound inequality we can write for this, 6 is less than n is less than 24. N has got to be between those two values. Questions on the process? Yeah.
Do we have to make the line thing?
The graph? No, that was just me showing, just to remind you what compound inequalities are. Maybe that, no, you don't have to graph it.
So that's
Okay.
the answer.
Yes. What this, again, we're not solving for n here. We really can't without more information here. But this gives us a range of possible values n could be based on the triangle inequality theorem. Arlene.
Will there ever be one where there is less than or equal to or greater than?
Not using the triangle inequality theorem.
Okay.
Because the theorem itself states that the sum of two sides must be greater than the third side. Yeah.
Do we have to do that third problem even though we know that it's not?
No. The reason why I put it up there is because we're kind of all probably at different places understanding what's going on up here. And so to see that third one and understand why we don't use it might be beneficial for some. If you get it, you don't have to write it. Okay. Let's do the last one because it's got roots in it, right? And we're all afraid of roots.
Too scared.
Yeah. What's the value of 3 root 81?
27.
How do you do 27, Jack?
I did the math in my head.
And what math did you do?
I did 81 divided by 9. And multiplied by, there's 9. Multiplied by 3.
So what this says, right, is 3 times the root of 81. Jack knew the root of 81 equals 9.
Yeah.
And so 3 times 9, we're dealing with a side length of 27. Okay? What's the value of 2 root 225?
15.
What?
15.
And then times 2, 30. The side length is 30. And then n. So don't let roots scare you. Okay? You know what they are. You know how to deal with them. Right? Just do the math. And you end up with something that's very easy to work with. Okay? What inequalities can we write that are going to be helpful? We'll just stick with the 2 of them here. What inequalities can we write that are going to be helpful? Rowan, give me one.
7 plus n is greater than 3.
Okay. 27 plus n is greater than 30. And what other one is going to be helpful? Kylie?
27 plus 30 is greater than n.
27 plus 30 is greater than n. The one that's not going to be helpful to us is the other combination of this. 30 plus n is greater than 27. And again, the reason why that's worthless is because 30 is already greater than 27. And could be anything. It gives us no information about what it could possibly be. Right? But the other two, we solved that first one by subtracting 27 from both sides. We get n is greater than 3. And we simplify the second one to get 57 is greater than n. What?
I don't get this.
Which part?
Kind of like after like what we're doing now.
So do you see how I got n is greater than 3? I used opposite operations to subtract 27 from both sides here
Oh yeah.
to isolate n.
So,
And you see where the 57 came from? I just added.
them.
Yep.
That's it.
Yep, that's all we've done here. Okay?
Yeah.
So then the inequality that we can write from this, what we know is that n has to be greater than 3, n less than 57. So our compound inequality is n is, 3 is less than n, which is less than 57. It's got to be somewhere between those values. Okay? How we doing, Jack?
And also, pattern, can't you just subtract so you just subtract the big number from the small number and then add them to find the answer?
I was so close. I was 6 minutes away from sending you out of here, and then tomorrow, just blowing your minds with the shortcut of how to get this inequality. When Jack comes swooping in,
Good job,
his
Dad.
superhero cape flowing. Jack saying, well, wait a minute, can't you just use these numbers here, add them to get the big number, and subtract them to get the small number?
Yeah, why don't we
Oh
do
my
that?
gosh, that's crazy.
Right? 9, 15, add them to get the big number, subtract them to get the small number. So close, Jack, but yes, he's absolutely correct. Okay? Will, turn around, please. He's absolutely correct. A shortcut to this is doing exactly that. Adding them will get you the high limit, subtracting them will get you the low limit. However, just be honest with me, if I showed you that from the start, would you have any context as to why it works?
Yes.
It works because of the triangle inequality theorem. But yes, Jack, that is a shortcut. Job well done.
Proud of you, Jack.
Okay, which actually that's going to help you a lot solve these two questions here. Okay, these are brain buster questions because I intended you to attack them without that piece of knowledge. But knowing what the smaller range is and the larger range is, it's going to that fact is going to help you with those two there. Okay, your homework is simply going to be the rest of the page. The two we didn't do up top, the word problem and the two brain buster questions, which all of a sudden got a little bit less complicated. And this will be due tomorrow. Questions, comments, concerns, complaints, compliments, congratulations, or criticisms? My compliments to Jack. All right, folks, that's how you math
Don't forget to like, subscribe.
with gusto.